Hi, my name is Gwangbin. In this video, I'll present our paper DigiFace-1M, 1 million digital face images for face recognition, which was a joint work between the researchers at the University of Cambridge and Microsoft. State-of-the-art face recognition models show impressive accuracy, achieving over 99.8% on label faces in the wild. These models are trained on millions of real human face images. Here are some of the commonly used datasets. While most of them contain celebrity images, datasets like Megaface collected images of the general public using Flickr. There are several problems associated with these large-scale face recognition datasets. First of all, they have ethical issues, including privacy violation and lack of consent. Following severe criticism, public access to several datasets has been removed. Secondly, the images collected by searching the names of celebrities often contain errors. For example, distinct persons with the same name are often labeled as the same person. People whose name can be written in multiple different ways are often labeled as different identities. Lastly, celebrity images or images collected from a particular website are severely biased. For example, most datasets have imbalanced racial distribution, leading to poor recognition accuracy for the underrepresented racial groups. To tackle these problems, we introduced DigiFace-1M, a synthetic dataset for face recognition. We can generate infinite number of faces using a generative model that is built from high-quality head scans obtained with consent. We have guaranteed correctness of labels, and we can reduce any bias in the dataset as we have full control over the face generation and rendering pipeline. We start by sampling an identity, which is defined as a unique combination of facial geometry, texture, eye color, and hairstyle. For each identity, we sample multiple sets of accessories and render the face images by varying the pose, expression, camera, and environment. Face recognition datasets should have a large number of images for each identity to encourage the network to learn a robust embedding. It is also important to have a large number of identities in order to learn diverse, discriminative embedding. We observed that an efficient way of satisfying both is to mix two datasets with different statistics. The first part of our dataset contains 720,000 images of 10,000 identities, while the second part contains 500,000 images of 100,000 identities. In total, the dataset contains over 1 million images, making it the largest synthetic dataset for face recognition. Aggressive data augmentation is key to reducing the synthetic to real domain gap. After applying random horizontal flipping and cropping, we apply two sets of augmentations, one for the appearance and the other for warping. Experiments show that both sets of augmentations lead to significant improvement in the accuracy. Here we provide a comparison against the state-of-the-art methods. SynFace is a recent method that is trained on synthetic face images generated using disco face scan. Training the same network with our dataset improves the accuracy across all datasets, suggesting that our rendered synthetic faces are better than GAN-generated faces for learning face recognition. Note that training a GAN requires a large-scale real face dataset, which can have unresolved ethical issues and bias. The performance gap from the methods trained on millions of real face images can be reduced by using the full dataset and by fine-tuning the network on a small number of real face images. We hope this dataset will be a meaningful step towards developing socially responsible face recognition models that do not depend on privacy-sensitive data obtained without consent. Here are the references, and thank you very much for listening.